I'm Ashton Addison from BlockWest Capital for Investment Pitch Media, and today on the Crypto Coin Show, we have back with us Jag Sidhu, lead developer of Syscoin, president of the Syscoin Foundation, and CTO of Blockchain Foundry. Jag, welcome back to the show. It's a pleasure to see you.
Oh, it's awesome to finally connect with you again. It's been a couple years since we've spoken. There's a lot to cover, so I'm glad to be here and glad to get a chance to speak to you on the show.
Likewise, Jag. Thanks so much for taking the time. And yeah, so much to cover with Syscoin. The protocol is just continually growing and keeping up well with all of the explosions that have happened in the recent 12 to 24 months, even in the cryptocurrency industry. So I would love to just kick off the conversation for those that they've heard of Syscoin, but they don't really know the details on just an overview of how you would explain Syscoin to somebody who doesn't know and isn't familiar with it.
I guess the elevator pitch is Syscoin is a combination of the Bitcoin stack as well as the Ethereum flexibility. Mm-hmm. And the takeaway should always be when you're assessing different layer one blockchains, because now the market for layer one blockchains kind of is a little bit dying off. More people are focusing on the application layers and the roll-up layers and this sort of thing. But the layer one blockchain is a critical infrastructure, critical plumbing to our global financial system that's coming up in the way we're doing things in the future. And it's not settled. Bitcoin is great at what it does, but it's not the only thing that's needed to reinvent the financial markets. There needs to be a utility-based, global coordinated financial system that's built on the blockchain or based on some secure layer built on the blockchain. So that's, there's still a fight to figure out what is needed at that layer to serve the future smart cities, IoT, AI, when embedded devices start to take onto the blockchain, what layers, what is the TCP IP stack that looks like at that point?
Mm-hmm. Definitely, and great intro there. And I've seen from following Syscoin for so long now, I feel like you guys are one of the OG layer ones. I don't know if it was 2014. Correct me if I'm wrong, but that was like before the explosion of Ethereum, and DeFi and NFTs didn't even exist. And we're seeing a lot of other layer ones sort of competing with Ethereum, but of course they're all trying to tie back and make a holistic, interoperable layer one, blockchain family where you can not have these isolated silos. Maybe you can talk about those recent developments leading into connecting back with Ethereum. I believe you guys were working on the bridge and how that's going with Syscoin.
Yeah, so we developed the first interoperable bridge with Ethereum back in 2020. And that was the ability for both the blockchains to seamlessly kind of connect and be aware of each other. And then, we saw kind of the writing on the wall with what Starkware was doing and some of the ZK teams were doing. And also the optimistic rollup teams and how they were evolving to create layer twos that will help scale up the layer one. And at that point, we, through our roadmap and vision, we analyzed that in order for us to really have a place or even be relevant as a layer one blockchain, we need to figure out what the core proposition of that chain is. And always our vision was to be a secure, decentralized settlement, like a court system. And as we added the EVM ourselves, at that point, something like the bridge would be effectively like using Seller or AnySwap or multi-chain, which are industry-wide bridges that can go from one chain to the other. So what we did was we developed the EVM. We set that as the base layer, fully decentralized and secure, parameterized so that we will build on layer twos. So what that means is we slowed the blockchain down to 2.5 minutes. We added finality through the masternode protocol, and that enables securing against some very important attack vectors in Bitcoin. The main attack vector of Bitcoin is something called selfish mining. And it's where the miners decide they want to censor transactions by just, making empty blocks, and they're not incentivized to do it, but sometimes market can be irrational longer than you can remain solvent. So you can see some situations where some guy just wants to censor the blockchain as long as possible before people lose trust in it and try to kill it off that way. So selfish mining is where the guy just simply doesn't respond to anybody. He's just mining blocks in his own way. He potentially could be trying to 51% attack it, but even if he's not 51% attacking, he's just saying, I'm not including any transactions here, or I'm not including any of your transactions or someone else's transactions. I'm going to censor those, creating a block. And if he has enough hash power, he could effectively enforce everyone else to not include transactions either. And that's what the selfish mining attack is. And in order to work against that, and some of these protocols have been working on creating complex versions of systems that can avert that as like an alternate blockchain. These are like Rootstock and Risk, and some of the other blockchains, adding very complex logic through the mining protocols. Instead, what really would solve that is something called finality. And what that means is once the block has been given enough time and enough nodes have heard about it, then you can effectively say that blockchain cannot roll back anymore. It's the same thing as sort of like what Ethereum is trying to do with proof of stake. And proof of stake is a totally different ball game, but the end goal is to try to create finality and a lighter blockchain and more green. And I effectively can say you can solve this problem in a different way without deviating away from Bitcoin's core proposition of proof of work. So once you have finality, then you can say you cannot roll back. So how does that fix this problem with Bitcoin? Well, not on Bitcoin itself, but since we are merged alongside of Bitcoin through our mining protocol, miners of the F2 pools and the foundries and the Binance pools, like these pools mining Bitcoin could participate in mining Syscoin as well, but they're not introducing any more extra work. They're effectively just they're green mining, right? They're taking the existing work of Bitcoin, applying it to Syscoin, and getting a reward based on that. Because the difficulty is high enough to solve Bitcoin, it should be high enough to solve Syscoin. So in this way, the miners are mining alongside. So we gain the security. The finality happens on Syscoin. So the finality is a way for us to say, okay, in Bitcoin, you can't do finality because there's no notion of supernodes or masternodes. We do have a notion of masternodes or supernodes, but they're not what a Bitcoin maximalist will say is a degradation of security, because anytime you have certain nodes saying, I will take responsibility for this section of the network, then you start to lose that decentralized aspect of everyone has to verify everything. Like imagine if the internet gets shut down and there's only a few nodes you can connect to. The only one you can trust is yourself, right? In situations, you have to be able to trust yourself, and that's it. You don't want to have to reach out to somebody and say, oh, let me collect information on the system through a consortium and then agree on the state. No, you have to be able to look up that data yourself. As long as one other person in the world is able to serve you data, you can recompute it yourself and say, oh, I'm convinced this is correct. So we introduced the concept of these supernodes or masternodes in a way where they're not actually participating in consensus, or they're not gatekeeping the blockchain. They're really just paid to run full nodes. If you're paid to do a job, and that's to take the blocks, take the transactions, send them around, and also this one specific thing, which is actually on a first come, first served basis, you are voting that you see what you see is a blockchain, you vote on that, on what that block is. So if the block comes to you and everyone else who's a supernode also sees the same block, then you can have a really good confidence model that, okay, that block must be the next one. Therefore, let's lock that in. And now we cannot roll back from that. So that is something that, it is consensus, But how we think about those problems are, we don't want to start to deviate away completely from Bitcoin's proof of work. That model works and is secure. And if you start to say, oh, let's start trusting the master nodes or the super nodes from telling us what the blockchain is, then that essentially ends up being a proof of stake model, right? That's what a definite proof of stake is, that those nodes are paid, they're going to be punished if they're not doing the work, and they tell us what the blockchain is, right? But that's not what we want to do here. What we're saying is we're taking the best of what proof of stake does, which is vote on what the blockchain looks like, and we're taking the best of proof of work in that if those people cannot agree, like if majority of them say, there's some 2 blocks, I don't agree what the current state is. Some of them say ones, others say another one. I can't sign a message globally in a message that can unanimously agree across the network. Therefore, I'm not going to do anything. I can't get a message to clear the network. I will fall back to Bitcoin's proof of work at that point. So, the devil's, when I say the devil's in the details, I really mean it. It's like, you can't agree on a specific message for finality. Therefore, you fall back to Bitcoin. So, why are we going so deep into the tech? It's because this is what differentiates something that will work at scale and global adoption and something that won't. If you don't have that, now you have selfish mining concerns. So if you're doing DeFi and there's big arbitrage opportunities called minor extractable value, people are going to exploit that. And imagine now you have rollups where Ethereum has Arbitrum and Starknet and ZK Sync 2 coming out. That's where all the users are going to be. Imagine if you can roll that stuff back 10 minutes or maybe an hour. That's going to cause huge ripple effects of convenience and possibly security, where you can't get your money back in some of those situations if you've done a transaction. And you just doing a normal commerce, I'm going to the shopping market to buy something. I don't want to have them call back and say, oh, your money didn't go through, by the way, you have to return your toothpaste. Like, it doesn't make sense. So having that finality gives the system some sort of semblance of security, especially when DeFi starts to get involved and more like real-time payment sort of systems. So that's kind of, our layer one. We think about decentralization, we think about security, we think about when the global market starts to take notice and start to use this system for real, not just a prototype, not just to create government use cases or lab projects. We're talking about when they push it to the consumers have to depend on this stuff. These are the sorts of things we think about without reinventing the wheel, by sticking to the core principles of what Bitcoin has done, but with the flexibility of what Ethereum has brought to the world through the EVM.
Definitely. All great points and so much to dive into in so little time. And with Bitcoin, what I really take away from that is the proof of work that has been running Bitcoin for the last 13 years is one of the strongest things in the blockchain industry. I feel like, if you can back on that, but then add in all of the other amazing things that you're adding in with Syscoin, like there's a lot of other consensuses that the ones that aren't using that backing on the proof of work with Bitcoin, I feel like don't have as much strength. So that's really great to hear. And you touched on the layer 2s there, Starkware, ZK Syncs, and bridges as well. I'm curious with the EVM compatibility with Syscoin to Ethereum. How does that work with layer 2s? And also just I feel like layer 2s emerged because Ethereum was sort of lacking in the speed and the costs of having optimal transactions. And when they moved to proof of stake, that's supposed to be solved. Where do you see layer 2s going when that happens? And how will you be working with the layer 2s with the technology you've built with Syscoin?
Yeah. Okay. Yeah. A lot to kind of pack there, but the layer 2 dilemma is mainly around the fact that we've analyzed what the optimal use of blockchains are at the layer 1, and it's not to put all the transactions for sure. So some of the other blockchains, the other consensus protocols that went after Ethereum and said, oh, we are cheaper. Those solutions, when Ethereum does emerge, they're going to evaporate. But still, having everything on the one layer, that's what we call a monolithic blockchain. And a monolithic blockchain just means that it's one layer settling or disputing or involving all of the financial activity. Instead, you can get a little bit smarter, and some of the the ZK proof stuff is what is transitioning us away from that model, is because now I can do my computation off of the blockchain layer one and move it off of into a secondary layer without actually reducing security, because the complete state, the double spend protection, what the blockchain is actually useful for, can be rolled up in a simple mathematical proof that's been done by even a central sequencer. Ideally, it becomes decentralized in that there's many sequencers, but you just need one person to give you that proof that all of the accounts in this system have been checked. And you can put that on your layer one, which could represent millions of transactions or state updates that happen within a size of a hash, for example. So now you can start to see that you're getting exponential scalability without adding all that cost back to layer one. So the layer twos, there'll be a bunch of them, or there could be recursive rollups where you have a base rollup and then many stem off of that, like in a tree kind of structure, and all rolled up into one state update on layer one. And the gas fees, many of the advantage of the other monolithic blockchains today, and it's happening now as people move off of Ethereum layer one, the gas fees are at multi-month, multi-year lows now. Yeah. And the advantages of some of those monolithic chains, even though they're being shut down, like Solana is having DOS issues and spam issues, those advantages go away and all you see are negative consequences of the monolithic design. So a modular design means you're using the blockchain as a simple court system. And the faster people realize that, the faster they'll move on to the fact that this is the only way we can potentially scale. So put your focus more on how do we create composable layer twos? How do we maybe make more efficient ZK sequencers? How do you do decentralized ZK sequencers? Those are the questions we have to focus on to scale up further. And if you analyze in that context, what a blockchain is, blockchain has two components. It has a data layer, like the database, and it has a CPU. The CPU is running on the database to make sure that the state is cryptographically consistent with others. So when you convince yourself by reading the data, by doing some work, and then computing what the state of that database is, and then convincing yourself that that's correct. So if you move the CPU off into layer two, then what you're left is with data. And what that data means is now different. Because now if all of your transactions are on layer two, the only thing you need to secure that system to be completely censorship resistant and same exact security as layer one is ensuring that the data exists for you as a user to be able to exit or move to another layer two if you want. And that data is a very specific sort of data. It's like in a ZK rollup, these are just account adjustments that get recorded somewhere, and someone has to be able to build up those account adjustments, or you yourself should be able to build up those account adjustments to be able to recreate the account states for you to give a proof to the blockchain layer one to tell it, oh, I own 15 sys at this account at this state. I should be able to move off, and here's my proof. Here's a signed message showing I own that address. And then the contract will say, okay, you own a part of this latest state. Yes, there's 15 sys available to that account. Okay, you can move off. And that needs to be trustless. Right? It needs to be as decentralized as possible. So now we've transposed the scalability problem from CPU bound, which is what it is in every monolithic chain. It's all CPU bound. We've removed the CPU bottleneck onto layer twos. What we're left with is with a data bound system, because on Ethereum, there's only certain block sizes. So the rollups are limited to how much data, because there's a lot of cost to put data on the blockchain and recorded it. The next step there is to solve some of the problems through more efficient ways to create data availability. And there's off-chain solutions. There's now going to be some on-chain solutions. With Syscoin, we have our on-chain solution. We think there's always going to be a market for off-chain data availability for people that want to take less security, like for example, GameFi apps, where they really do need, zero fee transactions or something like that, subsidized by some marketing or ad campaign or insurance costs. Those systems would be using off-chain data, off-chain CPU, and just using the blockchain as a court to represent there's a state transition. But the users still have to trust the off-chain system that you should be able to extract your data to be able to exit layer one. Whereas the on-chain data means I don't need to trust anyone but myself, and I could download the data myself, I can store the data myself, and then I can use a proof to exit that off of that system myself. And there's no one else I need to trust. So that's, when Ethereum is transitioning, they're transitioning to a proof of stake system. Their roadmap was always to do this since 2016-15, to move into a more of a sharded design. They are now reassessing that design into something called dank sharding, which is instead of splitting up the CPU into multiple shards, which is what they plan to do ever since 2016, like being able to do parallel computation by saying, okay, this group handles these transactions, this group handles these transactions, this group handles these transactions, go off in parallel and compute. And instead of doing that, they're saying, okay, why don't we just keep one unified execution system, just like it is today, but it's just the data that's the bottleneck now, right? Because everything's going to be on a roll-up, and the roll-ups are all parallel. So we don't need to worry about parallel execution anymore. Mm-hmm. The roll-ups cover that. What we need to worry about is the data. And so what they're now designing is with dank sharding, they're going to break up the different shards where the validators fit into different groups, and they're involved in basically sampling this big blob of data. Say like a gigabyte of data comes in, they'll break it up and say, okay, you guys deal with these many samples, you guys deal with this many samples. Together, we need a proof that all of the data exists. Mm-hmm. And now it's a data problem. So what Ethereum becomes is not a global supercomputer. It's a unified data availability layer to serve the CPU on the rollups. Now, I would question because you can already solve this problem, right? The way that they're going to put the data, you can already solve that problem in a way that Ethereum exists today. You don't need sharding to do that. I would argue you don't need to do the merge if you want to scale Ethereum today. You can keep it as is. You can introduce these data availability concepts on layer one and keep it fully secured, and nothing really changes on ETH except you add in a feature to be able to do the data availability in a more efficient way. That's what Syscoin is doing. Now, if you introduce new concepts and say, okay, now the data is broken up, and here's a proof that the data exists, but it is broken up. Now that whole idiom of me trusting myself only goes away, right? Because now I have to trust other shards that they have the data, and I'll be able to ask them at some time to be able to get me the data. Or at some time, I should be able to download that full gigabyte, store it myself. Instead, what we are sticking with is saying, no, everyone's going to be processing that 1 gigabyte. Yes, it's not as scalable as sharding, but it's more secure because decentralized matters first. In the event of a nation state attack or hyperinflation or internet goes down, I just need one other person to connect to in that mesh network. It's very secure, easy to get that connection. And I should be able to trust myself by gathering that data and storing it myself. And that's it. I don't need to trust anybody else. So, the jury's out on which system is better, but we are offering that alternative with the Bitcoin philosophy in mind of trust and verify yourself and keep that decentralization in mind, and then find the most efficient path you can with that in mind to be able to scale up general computation. And that's kind of the design decisions between what Ethereum is doing, what Syscoin is doing. And in terms of being interoperable, these would be just bridges that you can move Sys to ETH or ETH to Sys through the bridges. But there's no direct bridge because there's costs of doing that, and it's not 100% secure. For us, we try to say if the layer one is to serve for global adoption, it's got to be 100% secure, decentralized. there can't be any holes in there that would break. Like if you had a bridge to another blockchain, there's a potential breakage there. You can't have that system breaking down because of that.
Mm-hmm.
The only other thing I'd like to add is you started with, okay, we're secured by Bitcoin. Why doesn't Bitcoin actually do this?
Mm-hmm.
The Starkware guys are trying to convince the Bitcoin core teams and the community right now by saying, we'll give you an opcode so that you can prove through snarks and starks that execution has been done. Therefore, you should be able to do smart contract if you want, or prove your payment channels that way, right? But I would argue that Bitcoin is not designed that way, because if you start opening up DeFi and all sorts of external attack vectors, there's no MEV protection, and it's going to get pretty messy with how Bitcoin is designed. It's meant to be just a P2P transfer, and very simple that way. All the opcodes have known costs, and the interrelation between opcodes is well defined and known. Therefore, the system holistically can be almost mathematically verified to be intact and secure. Whereas if you start to open up these external systems with unknown behavior, unknown computation, unknown actors using the system, then you open up a whole bunch of weird situations that you can run into that can cause that layer one to fail. The other thing is that tokenomics are not geared towards utility, which is what a DeFi or finance is all about, utility, right? It's meant to be a store of value. So when we thought about Syscoin, we were like, we love the security, the proof of work. We don't love the tokenomics because people don't want to spend this stuff. We instead think about what is the minimum amount of inflation that you need to support a utility system where there's abundance of money, there's abundance of payment to these super nodes, there's abundance of payment to the miners, and some sort of static inflation that's going to be always around. So you're not relying only on fees. And these are the sorts of things we call that term minimal viable inflation. And we sort of modeled it after population growth, because we think that you shouldn't be priced out of this stuff, even after this thing is going to perpetually grow, maybe potentially grow up in price. But in your second and third generations after you've created the system, your kids and your kids' kids, they still got to be able to use the system because it's utility based. It's not a wealth preservation that's handed down from family to family. This is everyone starts from zero, and you have to be able to come in and use this system to be financially included. If you start to say it's got to be Bitcoin based, then you are creating you're creating wealth and also segregation of users. You have the same situation you have as the financial economy today, where people are priced out of the markets because they started from nothing and they can't catch up to anybody else. And you need to be able to have someone start from zero and be financially included in the system to be able to use it. So those are the core fundamental goals of when we started to introduce general computing. We had to think about these things when we introduced those concepts.
Great insight, Jag. Thank you so much for all of this knowledge. There's so much more I want to talk about with Syscoin, and that's why this is going to be a two-part interview, and people will have to catch the second episode to get the second half, because you guys are just working on so much stuff and you have so much insight on Bitcoin, Ethereum, and all of the protocols, and how to take everything and make it the best, the best of the best stuff in Syscoin. So for this, what we've talked about so far in this interview, what is the best way for people to learn more about Syscoin and these kind of documentations?
I think the best thing you could probably do is just reach out to, on the website, there's links to the Discord and Telegram chats, and the emails are there. And so if there's questions, we'd love to chat with people and love to ruminate over different ideas in the space and what works and what doesn't work. So we're always available for a friendly chat. And, we're out on the West Coast. So if anyone ever wanted to meet, we're out here, Western Canada and Western States, over a cup of coffee or whatnot. So, we're a pretty friendly bunch, and we'll be out in Consensus. We'll be out in Token 2049, and all the major conferences to meet people and talk about what we've provided to the industry, and we look forward to hear feedback from the researchers, the businessmen, the financial people, the governments, and whoever else is involved, because I think we have a touch point to help almost everybody with our solutions.
Incredible. And thank you for that. I will leave those links as well, just for the viewers to make it easy, in the description box below. And let's follow up, with the rest in part 2. And I'll talk to you really soon, Jag. Thank you so much.
Awesome. No, thanks, Ashton. Thanks for doing this.